My name is Jeremiah Hansen. I'm a principal architect on our field CTO team, and I'm really excited about this session. I've done a lot with DevOps and Snowflake in the past, and today we're going to talk about new capabilities within Snowflake to make it easier for everybody. So this is going to be hopefully a really fun session. We're going to cram a lot here into this short time. So I just want to start by covering our strategy around DevOps, and we have 3 pillars for the strategy. The first is about allowing customers to manage all of their objects declaratively, and I'll cover what that means in detail. And also to enable collaboration, it's the second pillar, to allow for DevOps and automation processes with CI/CD pipelines. And third, around telemetry and observability. And in particular, with the third one, we're not going to cover that in this session, but we actually do have another build session, logging and tracing for Snowflake applications, that you can watch to learn more. The term DevOps gets used to mean a lot of things. And when it comes to data, it can really mean anything from the data engineering pipelines themselves to managing the objects to other aspects. And so I want to focus us down here on this conversation. We're going to really spend time talking about how to manage our database objects, our Snowflake objects. So we'll treat that, but there's other things around data ops which get into more of the pipelines and the kind of end-to-end automation. So when we look at Snowflake, I've grouped our Snowflake objects into 2 buckets here. The core SQL-focused objects, and these are ones that are generally defined in SQL and are fairly simple to define. And then our developer-focused objects, and these are a lot of new objects that we have in Snowflake that are more than just a SQL definition. They often have an application behind them. So they've got Python code or libraries that are part of the object. And so we're going to focus this session, I'm narrowing it down again, we're going to focus this session on the core Snowflake objects, the core kind of SQL-focused objects. So that's what we're going to cover in this session. But we do have other examples. I have a quick start, for example, around Snowpark, the stored procedures and UDFs, around how to do DevOps with those objects. And we've got other resources as well for that. So we're going to save that for another time and spend our time here on the SQL objects. And just quickly, when we talk about doing DevOps for databases and data engineering, there are some unique challenges. And if you've been in this space, I'm sure this will be familiar to you. But when it comes to data, we have unique challenges with really the amount of data that we have. Having to maintain the state of that data is a big challenge. And oftentimes the data in your data warehouse only exists in your data warehouse or your data platform. You may not even have it in your source system anymore. And so you can't drop the data, you can't corrupt it. And if something goes wrong in a release, you got to figure out how to roll back. And all of that presents a lot of complexity for a data engineer and for managing your database objects. And then there's also testing, which is unique to data. So what we're going to go through today will help address a lot of these challenges with how Snowflake is building this new capability. But hopefully those are familiar to folks if you've been in the data engineering space for a while. Okay, so we've got it narrowed down now to our database objects. And the specific area that we're talking about here is database change management. And this is really the practice of defining your objects. So all of those database objects that we showed earlier, defining them in code, which means in a Git repository, and then deploying those objects and changes to them, to your database. And we'll talk about how Snowflake enables that. And this really, by having this practice and this capability, then you can automate, incorporate it into a DevOps pipeline and do other things with it as well. So this is really the core of what we want to do, is managing our objects in code and deploying them. So if you've seen some of my other DevOps videos, this slide might be familiar, but I think it's important that we spend just a second here talking about declarative versus imperative, because there are 2 ways to manage your database objects, and it's important to understand how they differ. The first is imperative. And what this means is, imagine I'm creating a table foo. What I'm going to do is I'm going to create a file. So each of these boxes represents a file. I'm going to create a file in source control called maybe V1 in this case. And I'm going to have this create table definition. And then imagine a month later, we need to add a new column. What I'm going to do is I'm not going to change that file. I'm actually going to go into my repository, create a new file. This might be called V2, where I'm going to add this alter statement to it. And these scripts, this is really simple. These scripts often have more than one statement in it. But the point here is I am creating the content for each of these scripts. And the tools, the imperative tools, they are really simple. They essentially they just run the scripts against each environment. and keep a record generally of what's been run. So the tool knows nothing about the database objects, the contents of the scripts, doesn't know which objects exist in Snowflake. It just knows how to run scripts. And the imperative is a very natural way. Most folks and customers that I've seen build solutions themselves, you generally start with kind of an imperative approach. Now, declarative is different. So with the declarative approach, you define, so say for our table foo, I'm going to have a file and source control that's called foo.sql, and I'm going to have the definition of that table there. And so when I deploy that, the first time is easy, of course, because the object doesn't exist. And so you can run this script as is. Where it gets challenging, though, is when I want to make a change. So imagine, again, I want to add that third column. So what I can do here is when I want to make that change, I actually go into that file and source control. And you can see I'll click back and forth. You can see I'm adding the third column to the definition. I save that into source control. But now the challenge becomes, how does you can't run that script directly because the table already exists. So what happens here? And this is where the declarative tools have to have a lot of capability and intelligence built in, because they have to actually compare what's in source control with what's in your database. And then they have to decide what's changed and how to migrate that object from one state to another. That's where you get the term database change management. But it's doing it in an automated fashion. So you don't have to write the alter table statement. The tool figures out how to do that. So declarative is definitely the gold standard. And what we're going to talk about today is Snowflake's declarative capability. Real quickly, when it comes to managing files, there's also differences. So in the imperative style, you're going to focus more on version numbering. And so you're going to store those scripts in more of a versioning kind of construct. When it comes to declarative, you're going to store them in a natural way with a hierarchical structure that matches your database, which is another benefit of the declarative approach. It's easier to manage the files and over time and see the changes and be able to identify quickly exactly which object you want. You go right to the one file and look at it. Where with imperative, you have to look through different files, search through it in your IDE to find the changes. So there's differences there. And in terms of tools, there are a number of tools out there today that if you're doing DevOps with Snowflake today, you're using likely one of these. There's a bunch of imperative options like Flyway and Schema Change. And then when it comes to declarative, there's really only one tool that offers a complete solution, and that's our Terraform provider, which now is part of the Snowflake Labs and contributed to by Snowflake. But there's some challenges with Terraform. It's a third-party tool, and there's additional things with managing the state and the rest that. But I'll talk about what Snowflake is doing, what advantages it offers. So I think we've covered this. There's the imperative style that's what most people are doing today because there's the most tool options. They're the simplest tools. We haven't had a great support for declarative with different tools, and I think I've gone through most of these challenges already about script naming and versioning and rolling back and recovery and all these things that are the challenges that imperative tools don't really help much with, but declarative does. So let's jump into what we've got now in Snowflake. And I want to start kind of simple here, but give you a mental model to envision. We're going to have 4 different Snowflake features. And I want to quickly show how they fit together. So we're going to first cover Git integration, which is really a building block, foundational. And then we're going to talk about a new feature called execute immediate from, which builds on top of Git integration. And then we're also going to talk about the Snowflake CLI. And then we're going to talk about the kind of core capability here is create or alter. And that really is our declarative capability. But you can kind of see how these pieces fit together. So we're going to go through those one at a time here briefly. And then again, in the demo, we're going to go through them one at a time. So the Git integration, most folks have heard about this already, but this is Snowflake's ability to essentially access your Git repository from Snowflake. And essentially the best way to think about it is a stage in Snowflake. When you make this connection, which I'll show you, it looks and acts like a stage inside of Snowflake. And then various objects like the one shown here on the slide can take advantage of that and access files when you define them, access files directly from that stage, which is backed by your Git repository. So it's an important piece by itself, though. It's not going to change how you do DevOps. And so a lot of customers, when they hear we have Git integration, think that means DevOps, but it really doesn't. It's really the create or alter that is the key. So, but this is a building block. So we're going to cover that first. Then execute immediate from. We already have a feature in Snowflake called execute immediate that lets you execute a script, a SQL script block. What this command does is it actually lets you execute a file that lives in a stage. So you've got a file that with some SQL commands in a stage. And if you run execute immediate from with that path to that file, Snowflake will run the contents of that script. So pretty powerful. And that stage can also be a Git repository. The third one here is the Snowflake CLI. And this is a command line tool, really our developer command line tool. At this point, we do have two command line tools. We've got the SnowSQL one, which has been around for a long time and lets you run queries against Snowflake. And then we've got the Snowflake CLI. So I know it's a little confusing. Long-term, though, the goal is to consolidate these tools and to have one, which will be our Snowflake CLI. And we've already added some SQL capability to it, which I'll show you. And then the final piece is create or alter. So this is that final Lego or final building block. And we've got, this is really our declarative capability. And so what we'll do is take that definition, and you can see we've added a new keyword in Snowflake, which is, so for your create definition, we have create or alter. You're probably already familiar. We've had create or replace for a long time, which is a different command that will essentially drop, if the object exists, it will drop in and recreate it. Create or alter won't drop the object. It will, if it's different, will update it to match your definition. So really, really powerful. And again, we'll show this in action, but that's the create or alter command. So if we put this all together in more of an architecture diagram, you can see the pieces as they work together. So you've got your files in a stage, you've got that Git repository, execute immediate is executing scripts that live in your Git repository. And those scripts can contain things like create or alter that can then change the state of the database. And that can all be orchestrated now, through the Snowflake CLI tool in a tool like a CI/CD tool like GitHub Actions, which I'll show. All right, so hopefully you're excited. There's a lot there, but hopefully the pieces are clear. So let's jump right into the demo here. And I'm going to start by showing you my GitHub repository. So this is the build database change management demo. And this is what I'll be working for. I'll access this here from Visual Studio Code, but I want you just to see these are the files and this is the existing repository. So I'm going to open up Visual Studio Code, my favorite editor. And by now, I think most people are aware that we have a native Snowflake extension for VS Code. If not, though, it's helpful to be aware of this. This is really important. It lets you work right from VS Code, connect to Snowflake. Provides a normal editing experience that you'd expect. So I've got that. And I'm going to actually run now my SQL commands here, my scripts from VS Code. So the first piece, if you remember back to our various diagrams, we've got is Git integration. And so I've got this set up in my account. The process to set up is pretty straightforward. So you create a secret, which in this case stores my username, my GitHub username and access token. And so this is a new Snowflake object to allow you to store sensitive information as an actual object in Snowflake and govern it accordingly. So I've got my secret. The second thing I create is an API integration. And this specifically is an integration with GitHub. So it's the Git HTTPS API. And I'm connecting it to my GitHub account. So that's what allows access to that particular API. And then the third object I'm creating is the actual Git repository object in Snowflake. And so this uses my API integration and my secret. And then I also tell it which specific Git repository to use. And in this case, that's that build database change management demo that I showed you. So once I've got these three objects created, the way I work with these is just like a stage. So I have my list command, which I just ran. And as you see here, there is a slight difference or slight nuance here. When I'm working with a Git repository, I have a few additional ways to browse the files. So I can look at them by branch. So that's the branches path or tags or commits. And I'm going to focus here with the branches, but we also have a couple show commands, which lets you show the branches in your repository. In this case, I only have one, which is the main, and same with tags. So that gives me the ability to browse. And then there's also a command which you'll see us use here, which is the alter Git repository and fetch. And that's how we get new or updates, how we pull down basic updates from the repository. So right now in private preview, this is read-only. Over time, though, this will be a read-write solution for Git integration. But you can see how easy it is now to start looking and working with these files. They just are like we had files in a stage. Okay, so that's the first piece. All right, so the second piece is execute immediate. To show this, I have a couple scripts that I put in source control in this folder, this 02 execute immediate folder. And let's just look at them really quick. So the first is this create inventory, and it creates a table called my inventory. And then it actually calls execute immediate from with another file. And I'll show you that in a second. And then it selects all the data from the table at the end. Inside the second script, it has a really simple insert statement. So this is showing that you can nest the execute immediate commands so that you can have, call one script, which calls another script, and so on. So that's what we have to work with here. And in order to execute that, you can see I can do I'll do my list command. So this will list out all the scripts in that folder. And there's 2 of them, like that we just saw. And now I can run, and there's no tables. I'll show you that. So if I do this execute immediate command now, so it's execute immediate from, and then it's just a path to that first script, the create inventory script. And I start with the stage and the branches like we looked at earlier. And you can see it ran successfully. Now I have a table that's called my inventory, and it returns the last statement, the result of the last statement in the script, which in this case was that select. So I can see my records. I can look at the tables again. I've got it now in my inventory table. So this is a pretty powerful feature by itself. And I think you can probably be a lot of creative solutions out there for how to use this. But this is available today in public preview. It's going to be GA shortly. And like it says, we can execute scripts that live in a stage or in a Git repository. So you can already start taking advantage of this today in other ways. But again, it's one of those core building blocks. Let's go on to the third piece. And this really, now this is the most exciting in the sense that this is the creator alter is, like I said, our declarative capability. So I want to show you how this works. And we'll start with a really simple example. So the first example here is I'm going to just list which tables we have. We just have the my inventory table. And the command, like I mentioned before, is create or alter. So we've got a create or alter table foo with 1 column. So we run that the first time and we get a table. If I describe this table, you can see that it has 1 column in it. So nothing too exciting. But here's where the real power comes in. Say I want to add a second column, like we did in that slide earlier, talking about declarative and imperative. I just come to the same, this would ideally be a file in source control. I add column 2 to my definition. And now I just run create or alter again. And what happened is Snowflake figured out, you can see I have 2 columns in the table. So Snowflake figured out that my definition had 2 columns, my table only had 1, and it figured out it needed to do an alter to change the state of the table. And that's really powerful. That really, like I said, is the core of this capability. And so for now, I'm just going to drop this table. We'll actually work with the my inventory one, but hopefully it's clear how that works. And one quick comment, the kind of our philosophy with this feature is that we want to have consistency between the alter commands and this create or alter command, this new create or alter command. So anything that you can do with create or with the alter command applies here, and any limitations apply here. So keep that in mind, but that's important so that if you do more of a procedural or imperative style operation against tables and a declarative one, they'll work the same. Okay, so we've got now the 3 of the 4 building blocks kind of outlined. I want to really, before we get into Snow CLI and doing the DevOps pipeline, I want to put this all together and show you how to make this work together. So first thing I want to do is, and in this case, we want to actually store that definition of that table in source control. So I've got this folder here called Snowflake Objects. And inside of it, if we expand it, I've got at the very bottom here, I've got this table called My Inventory. And it's the same schema right now that we had in the table. But you can see it's create or alter my table, My Inventory. And I've got it stored in a really natural way. So it's the folder structure is databases, and then the specific demo DB database or folder, sorry. And then schemas with the specific demo schema folder, and then tables, and then all my tables would be in here. And you can see this is, of course, really simple, but this is has been the best practice for managing your objects declaratively for database DevOps. So I've got this file, and now I want to deploy changes through this. So let me show you how that works. So what we do, we looked at the structure. I'll just show in that folder. If I do a list here, again, we've got two files in there. The one I showed you, my inventory SQL, and then this other deploy objects, which we'll cover in just a second. I can look at my table really quick and see we still have two columns. And I can run now with execute immediate this script. So this is just calling that one my inventory SQL script directly. And there's no changes as you'd expect because we had the two columns and we still have two columns. So that's our baseline. So now we've got that definition checked in. Now, if we want to make a change to it, what we're going to do is come into our source control. We'll add a third column here. So maybe we'll call this description, and we'll give it as a varchar. So we've got a new column we've added. We save it. We're going to check this into source control. So do a quick check. That looks like the change we want. And then we'll say add a new column. And we're going to commit that. And then I will just quickly push that change to our GitHub repository. So we've got a change now. I made a change to that file, checked it into source control. And now what I can do, if I want to run that, is I showed this command earlier. We can basically update our Git repository. So we can make sure we get all the changes from the master repository. And so that updated successfully. And now if I apply this change, so it's the same command I ran before, but the script now has been updated, we'll expect this to add a third column to the table. So it executed successfully. And if I now describe my table, you can see that we've got three columns in there, the new description column. And since we didn't give it values, in the command, they're all null at this point. But pretty powerful. You can see, hopefully you can now see in a simple example how we can tie all this together. So the final piece is around how we can automate this in a DevOps pipeline. So what we'll do is I'll quickly introduce the Snow CLI command, or a tool, the Snowflake CLI tool. And so first, I've done all the configuration already on this. We'll skip that step here. But I'm going to run a really simple command here, just a hello world example. So the syntax here is Snow is the name, those four letters, that's the name of the Snowflake CLI. And then the next argument is the type of operation we want to do. In this case, it's a SQL operation, but the Snowflake CLI tool supports already native apps and Streamlit and container services and Snowpark as well. So the idea is I'm just going to run a SQL command, and it's really simple. Select hello world, and this actually gets sent to my Snowflake account and executed. So very simple, but you can see this, in this case, how I can run this command. So what I want to do now is actually put this into an automation and into a CI/CD pipeline. So what I do, I create this script called deploy objects, which is in my main Snowflake objects folder. And it's simple. It just is calling execute immediate from, and it's calling that my inventory SQL script. And so you could imagine adding additional lines here to execute if you wanted to have other objects managed by this process. And then what I'm going to do now is go back to here. So we've got this script now. I can describe my table. I'm going to run two Snow CLI commands. The first updates the repository. There should be no changes here. So it'll tell us that there's no changes. And then the second one is actually through SnowSQL. I'm calling execute immediate from, and then I'm giving it this deploy object script, which then deploys all the objects that it needs to. So we've kind of added a layer of abstraction here, though, to help manage the process. And since I didn't make any changes to the script, we still have our three columns in there. All right, so that's the quick overview. Now the final step here, where we can tie this all together into a pipeline, is pretty exciting. So I'm going to show you, I showed you the GitHub repository already. Here I want to show you quickly the definition of the pipeline. So it's very simple. It goes through and it checks out, first of all, checks out the repository. It sets up, we're using Python 3.10 here, so it sets up Python. installs the requirements, which in this case is the Snowflake CLI command. There's a configuration step where we create a configuration file for the Snowflake CLI. And then the real process here, though, happens right here in this last step. We set some environment variables, and I'm calling the Snowflake CLI twice. And these are the exact same commands that I just ran locally, except for now I'm running them through this CI/CD pipeline, and I'm passing in that config file. But these are the exact same commands. And so I can run this in Snowflake. And I actually already, let's go back here to the 6. Say I want to go back to my script. Let's make another change. We can take the column out if we want. But let's add another one. Notes. And again, we'll check this in again. So just make sure we have the right change. Added. We'll commit that. Again, push that to the repository. And what this is going to do now is kick off the pipeline. So let's go take a look at it really quick. If I flip out and show you in GitHub, we'll go to the Actions tab. You can see that the added 4th column is running. I'll show you, this is actually when we added the 3rd column, this process kicked off as well. And you can see the steps here. So it's all the same steps. The key thing really is this deploy demo scripts, where you can see that it updates the repository and then calls the execute immediate from. So that's the core. That happened successfully the previous run, and this time I imagine it will happen the same. So we can look, it's already finished, and it did the same thing. It updated the repository. In this case, it needed to, and updated the object. And we would expect now, if we go back to VS Code and we look at our table, that we'll have the 4th column, which we do. So there you go. You can see it in action all the way through to, from a DevOps pipeline. You can see how these changes can be checked into source control declaratively and then deployed. So pretty exciting. We'll come back, just to recap. These were all the pieces that we just saw together again. So all the way through to the CI/CD pipeline. And really, I've covered already the benefits of declarative, but this really is the gold standard for database change management. Having that single source of truth, having this really helps with rollbacks. I mentioned at the beginning some of those challenges. This really helps with the rollback and recovery, and this kind of the patented Snowflake simplicity and keeping this simple. All right. Thanks for your time.